Thank you.
And you should be able to share your slides.
All right. Sharing that. Can you all see my slides now? Richard, can you see them?
Yes, I can see them.
Great. Let's just get that into sharing. Wait. Great. So thank you all so much for joining, and thanks Richard for the kind introduction and the opportunity to speak with you all today. I think this sort of weird time for everyone has been a great opportunity to learn and join some talks like this, and I've been listening in on a bunch myself, so it's a real pleasure and a privilege to be able to deliver one of my own today. So as Richard said, I'm now based out in San Francisco, California. I work at the Buck Institute for Research on Aging, and our mission is to help everyone live better longer. And my particular area of research focuses on ketone bodies for health span extension. As Richard said, here we go. I have in the past worked for companies, and I have equity interest in those companies. I'm also an inventor on some patents related to the use of ketone bodies. So want to start my talk with a slide showing carbohydrates, because I think that the story of research into carbohydrates for exercise performance is kind of telling and a useful framework for thinking about how we're progressing along our understanding for ketones for exercise performance. So back in the 60s, it was first discovered that if you mix sugar with some electrolytes, that could help the Florida Gators to perform better on the football field. But since that initial breakthrough, there's really been an awful lot more research that's gone into developing our understanding of the type of carbohydrate that's best for exercise performance, the timing and the dose, et cetera, et cetera. And so now we have a much more sophisticated understanding, but that was 50 years later. I'm just gonna ask everyone to check they're on mute one more time, that would be great. So I started work in this field in 2010. 10 years ago now, and in the last 10 years there have been around about 20 research papers describing the effects of different types of exogenous ketones before and after exercise. So we're really at the tip of the iceberg of this field. And so if you're here hoping for a definitive answer about how to use exogenous ketones for exercise performance, I'm going to go straight in with a spoiler and say the answer is we don't really know exactly just yet. So today I'll cover a few basic concepts that I want to keep in mind when we're thinking about how ketones are useful for athletic performance, go back into some of the basic biology of the differences between endogenous and exogenous ketosis, look at the different types of exogenous ketones, and then discuss how they might be useful for exercise performance and recovery. So let's dive in. So the first concept we need to keep in mind is that all sports exist somewhere on this continuum of bioenergetic and metabolic demands. So on the one end of the spectrum, you have these very high intensity, very short duration sports like bodybuilding and Olympic lifting. And down on the other end of the spectrum, we have like more my wheelhouse, so like Ironman triathlon. It takes a long time. It's not as intense. And really, maybe not even shown on this slide, you have ultra events that can even last several days. And so where you sit in on this continuum is going to determine your fueling and supplementation strategy. Another concept that's important to remember is that enhanced athletic performance on the day of competition is a function of a lot of small indirect effects that occur outside of that competition day. So in order to perform well at the Olympics, an athlete has to be able to maintain their recovery, avoid illness and injury, and also optimize their body composition. And you can target your fueling and nutrition to really look at optimizing one of these factors to indirectly improve athletic performance. And the final concept, just to sort of set the scene a little bit, is thinking about what actually is a worthwhile improvement for an elite athlete and how do we measure this in the lab. So especially for endurance athletes, the percentage difference here, you can see it's very small between athletes winning gold medals and then athletes in the top 10, you know, separated by points of percentages. And I love this picture from last year's Boston Marathon, showing here this athlete missing out on an extra doubling of his prize money by just a few strides. So for elite athletes, small differences really, really matter. For endurance athletes, it's kind of easier to measure their performance in the lab because we can put them on a treadmill or we can put them on a static bike or an indoor rowing machine. And that allows us to quite nicely replicate the demands of their event and test out the effects of different supplements like ketones. But for team sports, where there's an awful lot more variables, obviously there are a lot more people taking part, and strategy plays this really important role. So it's really hard in the lab to make definitive tests and statements around about which supplements are going to be most useful for these athletes. So that's sort of setting the scene a little bit. In the last few years, since 2016 really, there's been all of these fantastical headlines getting all excited about the use of ketones in elite sport. And having worked in companies that provide these supplements, I can say that World Tour cycling teams, world record breaking cyclists, NFL teams, and European Premier League soccer teams, a lot of these elite institutions are experimenting with exogenous ketones as part of their supplementation protocol. But as a scientist, we have to sort of keep a very level head and a perspective on the evidence as it's emerging. And as I said early in the talk, things are really still very early on. But I think it's certainly exciting to see the adoption, and getting feedback from people using these in the field has been very interesting. So with that as a backdrop, let's go back to some of our basic biology and explore the differences between exogenous ketones, so ketosis that comes from a bottle, and endogenous ketosis, so that's more like the ketogenic diet. Now, this term ketosis is, in my view, somewhat badly used and misapplied, because it covers a whole lot of biological processes depending on who's using it. But when scientists talk about ketosis, the way that they normally determine whether you are in ketosis is by making a measurement of ketone levels in the blood. So this technically is a state of hyperketonemia. Now, we measure the levels of this ketone body, beta hydroxybutyrate, or BHB. That's the easiest one to measure in the blood, and normally it circulates at the highest concentrations. And normally the threshold for ketosis is that the levels of BHB exceed 0.5 millimoles. And when this is the case, BHB can be oxidized as a fuel, but it also can have some signaling effects as well. Now, endogenously getting your body into this state of ketosis is kind of complicated, and there's many steps. So you have to restrict your carbohydrate intake, either by following very strictly a ketogenic diet, which is very low in carbohydrate and very high in fat, or you can fast or even starve, which is a more extreme version of fasting. But when you restrict your carbohydrate intake, blood glucose falls, blood insulin falls. This results in increased lipolysis, which is that magic fat burning weight loss effect of the ketogenic diet. But as a result of that increased lipolysis and fat mobilization, the fat that's released goes to the liver and is converted in part into ketones, and these accumulate in the blood. Now, exogenous ketones bypasses some of those steps. So you can either have ketone supplements that directly contain the beta hydroxybutyrate, so you consume them and they just appear as BHB in the blood, or you have a precursor that does require some ketogenic processing in the liver before it builds up as BHB in the blood. But this does mean that you don't have the carbohydrate restriction or the lipolysis, and so the low insulin and low glucose and all of those things that were a prerequisite for getting your body into a state of endogenous ketosis. So let's dive a little bit more into some of the details of the differences between these two states. With a ketogenic diet, it's quite hard to get very high levels of blood ketones. So a year-long study of type 2 diabetics on a telemedicine monitored ketogenic diet showed that on average they were sitting around about 0.5 millimoles. And that's not to say you can't get higher. We do hear reports of individuals getting up to, say, 5 millimoles, but it's harder to do. Strict dietary adherence and maybe also exercise in there as well. Whereas with exogenous ketones, the level of ketones that is reached really depends on the supplement that you take and how much of it you take. So with ketone salts, levels are typically a little bit lower, 0.3, maybe up to 1 millimoles. And then the ketone monoester, which we'll talk more about later, achieves flexible levels of ketosis between 3 and maybe even up to 6 millimoles. As sort of inferred by that, with the ketogenic diet, being more difficult and this natural process, it can take several days to get into ketosis and weeks, maybe even to adapt to the ketogenic diet. Whereas with exogenous ketones, within minutes of consuming the drink, ketone levels are elevated, but this only lasts a few hours. We don't know yet whether you need to adapt to get the maximal effect of this. We see that people on Western diets do get into this state of ketosis, and we also know that ketones are taken up into our cells through the monocarboxylate transporter, which is ubiquitously expressed, so everyone has this transporter. So we do think that everyone is placed to burn at least some measure of ketones. We don't know for sure whether there'd be a bigger benefit or a bigger effect, let's just say, if people were on a low carbohydrate diet and better adapted to burning ketones. So it's a big unanswered question. As I mentioned earlier, in the ketogenic diet, and this is particularly important for athletes, carbohydrate is by necessity restricted to a very low percentage of energy intake. And so this can result in depletion of muscle glycogen and of liver glycogen, and this can have implications for performance. Whereas with exogenous ketones, you can take them alongside regular carbohydrate feeding. And so this gives the possibility that athletes can oxidize either ketones or carbohydrates depending on the demands of the exercise, because both are present. And then finally, as I mentioned earlier as well, in the ketogenic diet, we have these elevated levels of lipolysis and elevated levels of free fatty acids in the blood. But actually with exogenous ketones, it's perhaps a little known fact is that what ketones actually inhibit lipolysis directly. And naturally this serves the purpose of meaning that ketone levels don't build up too high in the blood. And so when people say that you drink a ketone drink and you go into this magic fat melting state, actually that's not the case, because you're inhibiting lipolysis by consuming these exogenous ketones. I don't want to spend too long talking about the details of why ketogenic diet and endogenous ketosis, it might or might not be useful for athletes, but I just wanted to flag it up as a topic of a lot of debate in the literature. There's been a lot of opinion pieces, a lot of studies, and clearly being on a ketogenic diet has big implications for physiology, and we see especially big increases in fat oxidation. But in my opinion, when you look at all of the studies laid out side by side, there's neither evidence for a super benefit of endogenous ketosis for athletes, but also no clear evidence of decrements either. So I think really a lot of this is down to personal preference, and I'm kind of enjoying not wading too far into this debate because it can get somewhat heated on nutrition Twitter, and I don't want to get too much into it now. So we can talk about it at the end perhaps, but we'll leave that for later.
Brianna, sorry to quickly interrupt. There might be a few people in the guest waiting room. If you're able to just access that quickly and let them in, you can let them all in one go. I just can't do that at the moment. And
oh, there we go.
There seems to be quite a few people there that.
Yeah, there we go.
Thank you. That's very kind. Thank you.
That's good. Okay. All right. Welcome to everyone who's just joined. You can always catch up on the first few minutes of YouTube afterwards. Can you all just make sure you're muted, because then I won't get feedback.
Yes, and it is recorded, so if you missed the beginning, it will be online.
It's all fine. So I mean, this is as good a place to start as any. So having introduced a little bit of the background of the differences between exogenous and endogenous ketones, let's look at a little bit of the background as to the different types of exogenous ketones that are available, because this is very important when we're looking at all of the different research studies. So broadly speaking, there are 3 classes of exogenous ketones: ketone esters, ketone salts, and ketogenic agents. So let's unpick all of those a little bit. Ketogenic agents don't actually contain beta-hydroxybutyrate or the other ketone acetoacetate themselves. They contain precursors that can be very, very easily processed by the body to give a ketone bodies. And the 2 good examples here shown here are medium chain triglycerides, which are enriched in foods such as coconut oil. Medium chain triglycerides have a fatty acid chain length of 6 to 12 carbons, and that chain length means that they go directly to the liver and undergo rapid beta oxidation, and some of that spills over to form beta-hydroxybutyrate. And we also have our little cocktail emoji here, and that's the alcohol 1,3-butanediol. And similarly, that undergoes rapid processing in the liver to form beta-hydroxybutyrate rather than undergoing metabolism by the conventional alcohol pathway. So both of these ketogenic agents can achieve modest increases in blood ketone levels, maybe 0.5 to 0.7 millimoles based on the literature, but it's certainly not super powerful in terms of elevating ketone levels. Next up, we have ketone salts. So if after this talk you were to go away and type exogenous ketones into Google, firstly, I wouldn't recommend it because they'll follow you around the internet because they're also good at tracking your search history now. But most consumer products do contain ketone salts. So these compounds are BHB bound to a mineral ion. So it's typically sodium, calcium, or potassium. And a key point to notice about these compounds is more often than not, they're what's called a racemic mixture of D and L beta hydroxybutyrate. And this property of BHB is called optical isomerism, and it means the molecule has a handedness to it. So the way I like to describe it to people is that we have 4 fingers and a thumb on our left and right hands, and they're structurally the same, but they don't overlay on one another. And in biology, a lot of molecules have this property, and sometimes it can affect how our enzymes are able to process them. So, for example, our body is tuned to oxidize D-beta hydroxybutyrate as an energy source, but not L-beta hydroxybutyrate as effectively. And so when you consume these ketone salts, you're getting some mixture of those 2 isoforms, and one of which we don't really know exactly how it's acting inside the body. We don't think it's oxidized so much as a fuel, but it may actually be having some interesting signaling effects. So that's something that we're actually actively researching at the Buck Institute. And the final class is ketone esters. People like to think it's some kind of sexy, new, innovative technology, but actually these were first described in the 1970s. There was an awful lot of the sort of groundbreaking ketone work that was done in the 60s and 70s, and it seemed to sort of be forgotten a little bit before a more recent resurgence. But ketone ester refers to a compound where you have a ketone or a ketone precursor, and they're bound together by 1 or more ester bonds. Now, because we have BHB, acetoacetate, and then in terms of precursors, we have butanediol, different fatty acid chain lengths, glycerol, and then you could have these in mono ester configurations, di-ester configurations, and so on and so forth. There are really quite a large number of possible types of exogenous ketones, and all of these compounds may have different physiological effects and also different physical effects, such as tolerability and ease of formulation, that kind of thing. So when you see ketone ester, don't automatically assume that they're all going to behave the same. We have to unpick which compound is being studied to understand the expected effects of that compound. And that is really nicely illustrated by the 2 ketone esters that have been most widely studied in the research to date. So firstly, we have a diester of acetoacetate. It's 2 parts acetoacetate bound to 1 part racemic 1,3-butanediol. This ester hasn't been used that widely in clinical studies, as there were quite big formulation tolerability issues in the one study that has been run. But in the animal studies of this compound, it's been shown that delivering acetoacetate possibly has some better efficacy for some applications, such as oxygen toxicity seizures or maybe cancer. And that's an advantage over delivering just BHB. The other ketone ester does deliver more BHB. It's a mono ester, so 1 ester bond of beta hydroxybutyrate bound to 1,3-butanediol again. This compound was developed in collaboration between the University of Oxford, Professor Kieran Clark, and Dr. Richard Veitch at the NIH. And it's been very widely studied in humans, and this is the compound that's available in consumer-ready ketone esters as it stands at the moment. And studies have focused on the use of this compound in exercise, physiology, regulation on metabolism, and also regulation of cognitive function as well. So we're going to talk mostly about this ester because this is the one that has the most research in humans to date. Oh, we'll go there. I'm a bit excited there. One point just to re-emphasize again is that all of these ketone compounds deliver different levels of BHB. 3 in the middle you can see here is different doses of the BHB monoester taken either well fasted or well fed, or rest versus exercise. And so also the state that you're in when you take the exogenous ketone can somewhat determine the BHB levels. But under any state, and also the evidence here is a little bit more limited, it's been less widely studied, but typically exogenous ketones have this quite mild to moderate ketone boosting effect, really only just getting over this threshold level of 0.5 millimoles. One thing I would say as I watch the research unfold from the Buck Institute is we actually don't know what the threshold for efficacy is for these ketones, especially in non-exercise contexts. So, for example, a recent study of cardiac ketones on effects of ketones on cardiac function showed effects happening as low as 0.7 millimoles. So it may be that for some health effects, we only need these low levels, but maybe the speculation has been that for sport, we want higher levels of ketones to ensure efficacy. We can discuss that a little bit in a second. So we'll move on to the kind of, I guess, critical question of this talk, which is how do exogenous ketones, and I highlighted here potentially, affect performance. And I'll go back to my Gatorade slide and say we really are a long way from knowing truly which compound is best to use, for which athletes it's best to use, the dose, the timing, and also if you actually need to take it with any other supplements to unlock, unmask, or amplify effects of exogenous ketones. So keep all that in mind. We're really at the tip of the iceberg of exploring these compounds for athletes. But when we started this work, or when the researchers at Oxford started this work a few years ago, they looked to our understanding of starvation physiology to generate hypotheses as to how ketones might work for athletes. So we know that in starvation physiology, BHB is used as a fuel source. It protects our limited carbohydrate reserves and works in alongside lipid metabolism. And actually BHB becomes the predominant fuel source for the brain. And so we see this preservation of cognitive function, which might otherwise decline because of falling blood glucose. And so thinking about this role of ketone bodies provided the hypotheses that for athletes consuming ketones, BHB could be used as a fuel. It might alter carbohydrate metabolism, maybe do something to lipid metabolism as well. And there's also this speculation that ketones could improve or maintain cognitive function under the demands of exercise. So this is where this sort of the starting point for all of the investigations. And the first paper that really tried to address these questions was this publication from Cell Metabolism, headed up by my mentor, Dr. Pete Cox from the University of Oxford. And so this paper consists of a series of 5 studies that characterizes athletes coming into the lab after an overnight fast, and then they were given ketone ester and carbohydrate, or carbohydrate alone, isocaloric drinks, and then they were exercising at around about 70% of their maximal intensity. So an exercise intensity that for most athletes is normally heavily dependent on glycolysis. And so through that series of experiments described in this paper, we looked to unpick the metabolism and sort of see what was going on in the state of ketosis. So to go back to our original hypotheses, what's happening to the use of BHB as a fuel? So we first experiment, you can see here, we gave people a ketone drink and they either rested, which is the white squares here, or they exercised, which is these 2 bars down here. And you can see that this is the ketone levels, and ketone levels were lower when the same ketone drink was given and people exercised compared with when they stayed at rest. And there was also an intensity dependency of the ketone levels. So this suggested to us that ketones were being used or oxidized to fuel exercise. Especially given that we measured ketones in the urine and there's really very minimal appearance of ketones in the urine, not enough to account for this difference that we see here. So we did some calculations to estimate the amount of ketone oxidation, and we estimated it to be between 0.3 and 0.5 grams per minute. So I want to emphasize here that firstly, that figure is an estimate, and really we need isotope studies to look at ketone oxidation during exercise. And secondly, this figure, even if it is correct, 0.5 grams per minute, that's quite low in comparison with the conventional fuels of carbohydrates and fat, which typically range between 1 and 1.5 grams per minute. So whilst ketones do appear to be used somewhat as a fuel during exercise, it's not clear that they sort of strongly replace and become the predominant fuel as compared with carbohydrates or lipids. So to think about how ketones might be interacting with carbohydrate or lipid metabolism, we have to go back to our basic biochemistry. And I hope you all recognize this is the Krebs cycle. And mostly we're feeding ketones in here. So ketones are 4 carbohydrate intermediates. They're cleaved into 2 carbon intermediates, which is acetyl-CoA. And this builds up and accumulates inside the mitochondria and can have the effect of decreasing the flux through the carbohydrate metabolism pathway glycolysis. So the first thing to say is this has been shown pretty robustly in a number of in vitro and in vivo animal models. So it's a fairly well-established effects of ketones. And then second important thing to say is that in the sports science community, this has been the topic of quite a lot of debate because obviously high intensity exercise is really dependent on this glycolytic pathway. And so when we're thinking about the effects of ketones on carbohydrate metabolism, the paradigm has been, is it carbohydrate sparing or is it carbohydrate impairing? And we'll come back to that point as we look at some of the performance results later on. So what did we see when we looked at carbohydrate metabolism? So we have our athletes and they come in and they do their two hours in this case at 70% of VO2 max, and they have a pre-exercise muscle biopsy and a post-exercise muscle biopsy. And here you can see the athletes who had just carbohydrate in their pre-exercise drink. And you can see that the levels of glycogen in those muscles fell very substantially, showing again, this is very glycolytic exercise. But when we added ketones into this pre-exercise drink, there was hardly any decline in muscle glycogen at all. So we did see this sparing and or impairing or reduction of carbohydrate metabolism in the presence of ketones. So outside of the muscle, we also looked in the blood. Data that I haven't got on this slide showed us that we saw consistent drops in blood glucose when ketones were fed pre-exercise, but also we saw declines in blood lactate, attenuated rise in blood lactate in athletes coming in after this fast and taking either ketones plus carbs or carbs alone. And so during the steady state exercise, levels were around about 2 millimoles lower. And at the end of a maximal 30-minute time trial, levels around about 4 millimoles lower. And so we saw this effect consistently through all 5 of the studies in that paper. And if anyone here has ever had physiology testing done on themselves, they'll know the difference in pain 4 millimoles of lactate can make. I had a lot of that testing done when I was on the rowing team. And so this, for me, was a very striking finding that came out repeatedly in these papers. And then finally, just a brief discussion of the effects of ketones on lipids that we saw. So again, data that I'm not showing you here, but we did see a consistent decrease in levels of plasma-free fatty acids during exogenous ketosis. But when we looked in the muscle, the athletes consuming ketone ester actually had a much bigger use or decrease in their intramuscular lipid stores. So less lipid available in the blood, therefore potentially more muscle lipid being used to fuel exercise. So all in all, this metabolic shift that we were seeing, we felt it was very profound. And I'm not going to sort of quite spoil the ending just yet, but so the final study, we looked at performance. But before I talk about the results of that study in particular, I want to show you a table where I've summarized pretty much all of the studies that have been done with ketones taken before exercise and the effects on endurance performance. So don't get too much into the detail just yet, but focus over here on the right. You can see that we've got quite a mixed bag. So we look at the field at the moment, we have a couple of positive results, several null results, and a couple of negative results as well. So let's talk about the Oxford studies, the ones we were just discussing, because they're the ones that have seen these positive results. So I think important to point out here, we're getting ketone levels up to 2 to 3 millimoles. People are coming in fasted and then taking ketones plus carbs or carbs alone. So again, you see the ketone levels here, 0.25 and then nearly 3 at the end of the time trial. And athletes were going on average 400 meters further. It was an improvement of around about 2% in a cycling time trial. So just to make that study design very clear, 60 minutes of steady state at 70%, followed by a 30-minute time trial. So pre-fatigue and then time trial, 90 minutes total. This study is not published in a peer-reviewed paper, but you can access it via patent online, and it's also being prepared for publication, fingers crossed. This is actually I am one of these data points. This is how I first got involved in ketone research. This is rowers doing a 30-minute time trial on the rowing machine. And you can see again, blood ketone levels, 2.5 millimoles just pre-exercise, and then they fall during exercise, indicating ketone usage. And most of the athletes here improved in the ketone condition, many getting season's best, personal best, and actually one athlete also setting a world record during this trial. So again, a positive result for exogenous ketones here. But more recently, independent research groups outside of Oxford have run their own studies and not replicated these findings. And so we're going to discuss some of the reasons why that is now, but I would encourage you to go and read the discussion sections of these papers because the authors provide a really nice balanced discussion as to why there may have been differences between these results. I think one thing I want to emphasize while we have it all up here on the table is all of these studies had brought the athletes in and fed them a pre-test meal around about 2 to 3 hours before the test, as well as feeding ketones and carbohydrates. So overall, this is perhaps a little bit more ecologically valid and could have led to some of the differences that we see. So the first study that was published came out of Dublin City University and Dr. Brendan Egan and his PhD student, Dr. Mark Evans. And they ran a study with shuttle running, followed by a time to exhaustion shuttle run. And they found no difference in the ketone ester versus carbohydrate control group. Then they tried to replicate the study design of the Oxford study. They did a 60-minute pre-fatigue at 70% on the treadmill, followed by a 10-kilometer run. And again, they saw no difference between the carbohydrate-only arm and the ketone and carbohydrate arm. At the time, they speculated this was because their BHB levels, their ketone levels, were quite low, around about 1 millimole. And this was sort of reinforced by the fact that they didn't see changes in blood glucose or blood lactate, as we'd seen reliably throughout the Oxford studies. But really, I think my own thinking shifted somewhat due to this recent paper that came out about 2 weeks ago, or 3 weeks ago now, that came out of KU Leuven. Peter Hespel and his PhD student Yael Poff published this study where they had athletes come in and fed them a pre-test meal. They front-loaded the ketone supplementation so that ketone levels were high during this 3-hour preload block and would fall before the time trial and the sprint at the end of the testing period. So what they were trying to do was to see whether the glycogen sparing that we described in the Oxford study could unlock better performance in these tests at the end without the risk that ketones could be carbohydrate impairing the higher intensity performance here. So this was, theoretically a really good strategy to protect carbohydrate reserves and then sort of unleash carbohydrate metabolism in these latter, more intense parts of the test. Critically, they got a muscle biopsy here at the end of this time trial so that they could look at muscle fuel utilization between the difference between conditions. And you can see that their BHB fueling strategy worked really nicely. They had their highest levels during the 3-hour sort of pre-fatigue part, and levels fell lower than 1 millimole before the time trial. But all that together resulted in no difference in 15-minute time trial performance and no difference in maximal sprint timed performance. And when they looked inside the muscle, they saw no difference in muscle glycogen usage at the end of the time trial, and also no statistically significant in any ways difference between muscle intramuscular triglyceride usage as we'd seen. So I kind of wish that Brendan Egan's 10K study also had muscle biopsies, because to me, the levels of the changes that we saw in the Oxford study were so stark that I was very surprised not to see them replicated here. And so it kind of led me to thinking that maybe this pre-feeding of the meal was just a huge factor that was kind of overriding the effects that we'd seen of exogenous ketosis. So I think, I'm watching this space evolve with a lot of interest. It was surprising to me there was such big differences between the Oxford studies in terms of metabolism and the Belgian studies. But there's still a lot of questions to answer. And one thing that's been thrown up recently is this, more recently people have been measuring blood pH during the experiments with exogenous ketones and seeing that ketones cause this metabolic acidosis. And that's actually something that we could address with further supplementation and see if this interacts with the effect of ketones on exercise performance. To go back to our little table here, one other study I want to call out is a study of the acetoacetate ketone ester in elite cyclists doing a 31-kilometer time trial. They actually saw a decrease in performance of around 2% in this study. You can see the results here. But they, as I said, this acetoacetate ketone ester has been not studied very widely before, and so people aren't very experienced at formulating it. And they note in the paper that a lot of athletes had mild to severe GI issues. And as an athlete myself, I think that this was probably quite a big factor in the decrease in performance. It's hard to perform when you're feeling really nauseous. And one athlete actually couldn't complete the trial when he had the ketone ester. So I think that the implication of the title of this paper was that there was something to do with ketosis that impaired cycling time trial performance. And actually, I'm more of the opinion that it was the GI issues that were experienced by almost all participants that drove the results that they see here. So I'll be interested to see what happens when that ester is formulated better. Quickly to touch on ketone salts, there have been a few studies here, and I expect there'll be more in the future because these are easier to access, but low levels of ketosis and no clear effect on performance. One study actually seeing a decrease in performance. Then let's go a little brief discussion of sprint performance, because as I said, there's been a lot of concern around if ketones might even impair sprint performance. there doesn't seem to be any sign that this happens just yet. So this is more intense, high intensity studies of ketones taken before exercise, and they consistently show no effect on sprint performance. And then quickly to move on and talk about cognitive performance. So again, this is a little bit early to be making definitive statements, but there's an interesting signal that ketones could be affecting cognitive performance. This is the study from Brendan Egan's group, which I talked about earlier with the shuttle running and soccer simulation. And the athletes had to complete these cognitive tests. So if the arrow is pointing to the right and the instruction is direction, you press the right-hand button. And if the instruction is side, then you press a button on the side that the arrow is sitting. And so this is a test of executive function. And pre to post exercise, athletes receiving just carbohydrate got more answers wrong after exercise, as whereas athletes with receiving ketones got the same amount of answers wrong. So cognitive performance was maintained with exogenous ketosis. And this is an interesting signal, and it was statistically significant, but it's important to note that in some of the other parameters that were measured, there was no difference. So it's still pretty preliminary. I know that there's work pending coming out of Oxford, and also some work that I was involved in with the US Special Forces that's looking at the effects of ketones on cognitive performance under conditions of extreme exercise or in extreme environments. So I think, I'll leave that there, but this is an area that I'm personally following with interest. So to wrap up this section on performance, we know that in certain conditions, certain feeding conditions, exogenous ketones profoundly shift the metabolic phenotype of exercise, but it is possible that this feeding condition is a really important determinant of that effect and ultimately of any performance effect. In terms of sprint and cognitive performance, it's too early to say for sure. For sprint performance, there's no clear evidence in my mind anyways that ketones decrement that high level of sprint performance. And conversely with cognitive performance, I'd say that I'm optimistic that there's some signal that ketones could be useful there. But overall, there's still an awful lot to do before we make definitive statements and recommendations for athletes going forwards. So in the last part of the talk, I want to talk a little bit about taking ketones after exercise as part of a recovery and adaptation strategy. We think when we're thinking about sport, it depends whether we're in a training or performance phase as to how we approach recovery. So if we're in a performance phase, we really want to get the refueling done and everything optimal so that we're ready to go again for that next performance, as well as in the training phase, there may be some times where you're happy to run like a bit low on carbohydrate or stress the body a little bit more to force that adaptation. Other things we're thinking about is rehydration. As I just mentioned, recovery of these muscle carbohydrate stores that can depend on that performance versus training phase. And then another really important thing is looking after lean muscle protein balance. So maximizing growth and repair because muscle is broken down and can be adversely affected by periods of training overload. So this is sort of what we're thinking about as part of a holistic recovery nutrition strategy. And so in the first part of the talk, we've been kind of up here looking at these effects of ketones on acute substrate utilization. But there's an awful lot of direct activities of the ketone body BHB that could be affecting more of these recovery pathways. So before we jump into talking about protein metabolism and glycogen metabolism, I just want to highlight down here that in vitro and in animal models, there's some pretty compelling evidence that ketones can inhibit histone deacetylases and thus indirectly decrease oxidative stress. Now, this could be useful for recovery, but although it may blunt adaptation, so you'll have to be mindful about how this is used. Also, there is good evidence surrounding the use of ketones as an inhibitor of the NLRP3 inflammasome. So this is a part of the inflammatory response to infection. And it can be activated by, for example, aging, it kind of activated over time. So we think, again, that adding exogenous ketones can dampen this response. And again, this could be useful as part of the recovery and adaptation phase. It's very, very hypothetical at this stage, and there's not very many studies that have really addressed this in humans and not at all really in athletes. So it's a bit early to comment, but I think it'll be interesting to see more work come out looking at these two pathways in the future. We'll focus specifically now on protein metabolism and glycogen metabolism. So if you take ketones after exercise, there's a possibility that they could help with glycogen resynthesis. So the first study gave a ketone ester drink alongside intravenous glucose after depletive exercise. And the results showed that the glucose infusion plus ketone drink did in fact increase muscle glycogen resynthesis. But this state of just kind of grabbing a needle and infusing glucose straight into the blood, that's certainly not something that any elite athletes could get away with doing. So a more recent study, again from Peter Hespel's group, looked at a ketone carbohydrate protein drink, I guess a little bit more like what we'd have in our post-workout bag. And in that setting, adding the ketone ester to the drink did not show any significant difference in post-exercise glycogen recovery levels. So these are the only two studies that have looked at glycogen recovery. And maybe this one is a little more ecological, but again, there's sort of some signal there that there could be something worth investigating as part of future efforts. Next up, muscle protein turnover. So again, Peter Hespel's study that I just mentioned using this ketone ester plus carbon protein recovery drink also looked at activity of the mTOR pathway, and mTOR is heavily implicated in muscle growth and muscle protein synthesis. And they found increased activity of this pathway following this ketone ester drink. And they also looked in myocyte model in vitro and saw increased muscle protein synthesis in this model. So positive result, but this is the only study that's looked at this in athletes. There has been some non-athlete work that's used exogenous ketones as infusions in very catabolic states, so bacterial infection, and shown that there's a protection of muscle protein balance there. I think there's quite a strong signal, especially from a lot of this historical ketone work, that this is an area that's worth exploring for athletes looking to maintain muscle mass as part of intensive and catabolic training. And all of this is sort of somewhat tied together by this another study that came from Peter Hespel's group. The Hespel group is very, very busy studying exogenous ketones. They ran a fantastic study that looked at ketone esters given 3 times a day after 2 sessions and then once before bed. Fit young men who were definitely fitter by the end of the study because their training went from 4 hours a week up to 13 hours a week. They were understandably kind of tired, and they had blunted resting heart rate, blunted maximal and submaximal heart rate, and increased nocturnal urinary noradrenaline and adrenaline excretion. But this was much higher in the control group that did not receive ketones versus the group that received ketone supplementation. And actually, the group that received ketone supplementation increased their training load that they could complete, and they were completing regular 30-minute tests, and there were higher power in those 30-minute tests in the group that was receiving ketones. So it was quite an interesting signal, but this paper, in my mind, couldn't really identify exactly why this was happening, and there were some important things that weren't controlled that maybe affect our ability to make conclusions from this paper. So they identified this interesting hormonal marker, GDF15, as being one of the things that consistently diverged between the ketone ester and control group. That GDF15 is implicated in some inflammatory diseases, but otherwise there were no changes in cytokines or other inflammatory markers. And a notable thing was that the athletes were not having a controlled diet, and so the ketone ester group ended up eating more than the carbohydrate control, or the control group, let's just say. So it could be not a direct effect of the ketones on performance, but an effect of the ketones to help maintain energy intake, which then improve performance. So it's hard to unpick exactly what's going on here, but I'd say it's a very interesting signal. And anecdotally, this is how a number of teams use ketones as actually a recovery, in cycling teams, using ketones as a recovery during these super long Tour de France and Grand Tour stages. So again, I'm afraid to wrap up this section with sort of more questions than I'm giving you answers, but in terms of recovery, I think it's interesting to, there'll be interesting further work done on glycogen effects, protein effects, maybe a better controlled in terms of the feeding of the athletes overreaching study, and much more work still to be done to look at these other signaling effects of beta-hydroxybutyrate on inflammation, oxidative stress, for example, and how that can impact recovery and adaptation. But we're still a long way off from being able to say, take 25 grams of ketone ester along with 25 grams of carbohydrate and 25 grams of protein twice after your cycling stage. So, we're a long way off being able to do that, but there's some interesting biology still to be got at. So to sum up really everything that I've covered today, I hope the little nuggets that you take away are firstly that exogenous and endogenous ketosis are very different states, and we can't kind of conflate studies of the ketogenic diet with studies of exogenous ketones. But if you are going to take an exogenous ketone, again, you have to be mindful of which one you're taking, because each type of exogenous ketone has different physiological and physical effects. One of the critical ones being this level of BHB delivery, but also these physical characteristics of tolerability, taste, and price ultimately are going to have a big impact of how easy it is for an athlete to incorporate these into their routine. So really there's a lot of work that needs to be done into developing new exogenous ketones, making them more accessible and more functional. In terms of the work validating effects of exogenous ketones in athletes, there's some preliminary evidence around endurance, cognition, and sprint. There's some good signal, but no clear data there yet. I think really what we need to do is address the context, so whether training status affects ketone utilization, habitual diet, because all of these studies have been done in athletes on a Western diet. We don't know how exogenous ketones would affect metabolism in athletes on a low-carb diet. Another really important context that has not been yet investigated is gender. All of the studies that I just talked to you about were all in men, apart from one of the Oxford studies that had 2 women participating, and actually the Rome study did as well. But I mean, predominantly these are done in men, and so maybe there are gender differences. And we see in our animal models at the Buck, we see very profound gender differences in ketone metabolism. That's be interesting to address. And then also, you know, do you need to supplement with ketones for a week before your big marathon race, or can you just take it one off before? We don't know whether there'd be an effect of ketones with a longer supplementation regime. So a lot still to answer here in terms of sport. But, you know, I don't want to get too distracted, but now a lot of my research focuses on clinical uses of exogenous ketones. And if you go on to clinicaltrials.gov, you can see that there's this really broad range of studies from heart failure through to alcohol withdrawal, through to metabolism, neurological function. And so my belief is that ketones and exogenous ketones is this really powerful tool to switch metabolism. They're a real metabolic switch that could be useful in a lot of conditions of energetic stress. And exercise is one condition of energetic stress, but really energetic stress underlies so many health conditions that I'm excited to see whether research in this area pans out over the next 10 years or so. So with that, I'll wrap up and just really call out my mentors at the University of Oxford, Professor Kieran Clark, Dr. Pete Cox, and Dr. Rhys Evans, who really spearheaded running all of the studies which I've talked to you about today that came from Oxford. All of my colleagues at the Buck have been fantastic mentors to me, and also Dr. Brendan Egan and Dr. Peter Hespel. I've been fortunate enough to work with them on presentations and publications, and their discussion with them has really helped me sharpen my own opinions and viewpoints on this kind of somewhat controversial topic. So I want to thank them for their help as well, and open the floor to questions for 5 minutes. And
yes, yeah, 5 minutes. Let me just reclaim the host so I can help with the questions. And I'm just going to bring in, firstly, amazing talk. I won't take up the time with the accolades. I think every time I came up with a question, you answered it on your next slide, and you summarized work beyond what you're doing with others really well. So great talk. I've got a question for Nick, who's a lecturer with us at Roehampton. So I'm just going to unmute him, and he'll come in and ask the question. I think you need to come in, Nick, if I can find him.
Can you hear me?
Yeah, yes. There we go. Go ahead, Nick.
Thank you, Brianna, so much. That was a fantastic talk, a really wonderful synthesis of the information in the field. My interest is more aligned to metabolic health and disease rather than performance sport. And a couple of quick questions. The first one, you mentioned Professor Clark, and I saw she had a study published last year looking at 28 days of ketone monoester ingestion 3 times a day. And they showed it was safe and tolerated well with few side effects, but showed no real benefit on body mass, body composition, glucose, triglycerides, any of the metabolic outcomes. So I'm just wondering, are you aware of any data looking at these kind of outcomes, longer term intake of ketone monoester in people with diabetes or pre-diabetes?
So that study that you're referring to was done in healthy individuals. And I believe there are a couple of markers in the paper. If you go through it with a tooth comb, so for example, I think CRP, C-reactive protein levels decreased in that study, which was an interesting sort of little bit of signal. But as you said, like broadly speaking, no changes. But personally wouldn't expect to see those things necessarily change in a healthy population. And I know that at Oxford, they're running a study with the same study design in diabetics and I can't remember whether it's diabetics or pre-diabetics, because in that study, there are a few participants who had higher fasting levels of glucose and glycosylated hemoglobin at the outset. And those participants did see changes in those markers. So it may be that in a healthy, otherwise healthy individual, you don't see these changes. And really we need to definitively answer that question in a pre-diabetic and diabetic population, where I'd expect to see perhaps a bigger effect. So in answer to your question, there is a study going on at Oxford that'll be 28 days looking at that metabolism in diabetics. And there's also work going on with Jonathan Little's group over in the University of British Columbia. He's published a couple of studies that have shown that ketone esters can attenuate the blood glucose response to an oral glucose tolerance test. And they're looking at running a chronic dosing study in pre-diabetics as well. So yeah, it's certainly an area of active research between those two institutions, at least.
Thank you very much. If I may, I have a quick follow-on question. In that study, they give the ketone monoester 3 times a day. As you know, the concentrations in the blood of beta-hydroxybutyrate drop within some hours. Are you aware of any research into long-acting ketone monoesters?
Yes, I know that a lot of people in this field are trying different formulation tricks and different chemistry tricks to try and generate, I guess, what you'd call like a more physiological steady state level of ketones. Because if you go away and look at some of the publications that I was involved in, you get this peak within 60 to 90 minutes and then it drops off within 3 hours time. And so there are different groups looking at ways of prolonging the release of beta-hydroxybutyrate. And I think that'll be the next generation of supplements that appear and that may have more maybe less relevance for performance athletes who might need that spike, but a more relevance for a clinical or wellness population where a slightly lower level, but for longer would be better.
Thank you. thanks,
Nick. Brianna, conscious of time, it's now...
I do have more. I'll be a little bit late for this call.
You're okay with that? You're enjoying yourself, I can tell.
All right.
I have a quick question about the backlog of acetyl-CoA. You mentioned where the ketone esters or ketones are coming in, and I'm wondering what that means in terms of how we measure things like insulin sensitivity, because that's related to what Nick's question is. So, if we're getting a backlog of acetyl-CoA and there's less glucose entering the system, and then we're measuring insulin and glucose and maybe isotope glucose, are we going to see, do you think, an increase or a decrease in insulin mediated glucose uptake in the post-exercise or post-ingestion sort of?
Yeah. So to go back to that study which used the glucose infusion, they had to infuse more glucose to achieve a steady glucose level, and the insulin secretion was increased. So it looked like insulin-mediated glucose uptake was increased in the presence of ketones. Now, part of that might be because of the decrease in free fatty acid levels, and we know that free fatty acid levels affects GLUT4 translocation. So in the short term, that could be part of what's driving that effect. But it's really we're going to have to do some of these isotope labeling studies to see what's actually happening dynamically to metabolism, because anything that we do just measuring in the blood or even taking a muscle biopsy and measuring in the muscle is just giving us a snapshot and is not really telling us about the dynamics of the system.
Yeah, I agree. And I think that's something we want to pick up on maybe tomorrow if we've got time. Thanks. Question from, sorry?
One more.
Okay. Any thoughts on BHB infusion on vascular health or impact?
Oh, it's super interesting. I mean, it was so personally the journey from being an athlete in a ketone study to like a PhD ketone researcher, more focused on sport, and now this like health focus that my research is taking and an aging focus. It's been amazing to see people using ketones in so many diverse studies. And recently there's been studies looking at the effects of ketones on lymphangiogenesis, so the formation of new lymph vessels, but also on vascular senescence, and so health of blood vessels as they age. And both of those studies showing like health promoting effects. So ketones increasing lymphoangiogenesis and ketones decreasing vascular senescence markers. So, I mean, it's certainly an interesting field. One thing that we see as well in some ketone infusions is that there's vasodilation. So there's in studies of the heart and the brain, the ketone infusion increases the blood flow to the heart and the brain. So there's definitely some kind of direct and an acute vasoactive effect of ketones, but possibly also this sort of like long-term senescence type, protective effect as well. So yeah, it's very interesting, and I think it's an area to follow. I have to drop now, but could you copy the questions? And if you share them with me by email, I can try and answer some of them, and we can figure out a way to distribute to people who are here.
Yep, I'll do that before I go. Just to say thank you again, Brianna, and for putting up with the password issue. Great talking to you and great seeing you again. Thanks for your talk tonight, Brianna.
Thank you everyone for coming, and I hope to connect with you all. I'm on Twitter if you want to follow me and ask any questions there. I'll do my best to get back to you all.
Great. Thank you very much.
Bye-bye.
Nice work.
How are you doing, Andy?
Good, how are you?
Yeah, I'm good. I'm good. I had a Zoom issue. It required a password for some reason this time around. No doubt I'll get to the bottom of it before next week's.
Yeah, all you have to do is go to the meeting settings and disable require password.
Yeah, I did that frantically with 5 minutes to go, and that's where I came up with ketone, because it just wouldn't let me do that. So I had to just go with a password I thought would be pretty user-friendly. Just trying to save the chat. I'm not sure where it's saving to.
I think it automatically saves when